I'm Myles. I work at a small disruptive startup called IBM. I contribute to the project Node.js, which a few of you are familiar with, but just, the opinions in this talk are my own. Versions, how do they work? So versions are a lot like magnets. And, stick with me on this. Versions are a lot like magnets, primarily in the sense that people are pretty darn confused about how they work. Real talk here, this stuff is complicated. There's a lot of moving parts, but it's always important when thinking about large systems to remember that just because you don't understand everything doesn't mean that you can't contribute in a meaningful way. So let's start with small pieces and build it up and see how we can go from a simple concept like Cember and build it up to a complicated release strategy like we do with Node.js with multiple release lines. So what is Cember? I'm going to make an assumption that many of you have seen a version number before, but how many here have heard of the term and understand what Cember means? Can I see a raise of hands? Awesome. I'm really excited to see that. So in Cember, we have digits. We have a first digit, which is the major, the second digit, which is the minor, and the third version of the patch. And I like to think about Cember as a contract. It's a contract for API developers and for software developers to let the people know who are consuming their product what has changed, how has it changed, what can I rely on, and what's happened. So let's talk about what these individual things mean. What's a patch? A patch is any change that does not change the behavior of the application or software, and it also does not add any new features. Generally, a patch can be a security fix, a bug fix, documentation update, test updates, metadata updates, anything at all that does not add a feature and does not change functionality. What is a minor? So a minor is anything that adds a new feature. And the reason why this digit is important is that it's good to let people know that new features have been included because they may not be as stable as features which have been tried, tested, and true over time. So a minor bump lets people know, hey, there's new features in here. They may not be as stable as features from before, but generally you should be able to upgrade a minor and not have any behavior changes to the rest of the system. This means, like as you'll see when you set up stuff on NPM, generally you can bump your dependencies if there's a minor release and not worry about regressions. But because there's new features, and those new features may be integrated or interact with other features, and we're dealing with a big system, there could be things that are unexpected. So you may want to be more conservative about your upgrading. And what's a major? A major is any change that modifies the contract. It is a breaking change. It modifies the contract of the API. It could be the arguments of a function changing. It could be the deprecation of a function. In Node, any changes to an error message right now is actually considered Cember major because some people rely on error messages for doing things. There's actually some interesting work that James Snell is doing to try to abstract out the error message in an error code so that we can change error messages without Cember major changes and also internationalize error messages, which is pretty cool. But I'm not going to tangent too much. A major change is a breaking change. And we'll get back to this in a bit and discuss a little bit more about what a breaking change is. So Node has a number of different release lines. We have our current release line, which is v6.8.1, which was released last Friday because we released 6.8.0 on Tuesday, and there were a couple regressions, and we immediately patched them and got it out. We have an active LTS line, which is v4.6.0. And we have two maintenance release lines, v0.10.4.7 and v0.12.16. Quick little note, in case you don't know, 0.10 is end of life. It finishes October 31st. We will not be doing any more 0.10 releases after October 31st. And v0.12 is end of life December 31st. We will not be doing any more 0.12 releases after December 31st. It's time to upgrade. It doesn't mean that you need to upgrade. It just means we're not going to be doing more releases. A lot of this was based on OpenSSL. The version of OpenSSL that 0.10 and 0.12 are running on is itself end of life at the end of the year. So we can no longer securely release Node and know that the TLS and OpenSSL implementation are not going to be vulnerable. And if you've been following the OpenSSL project, there's been a lot of CVEs. There's a lot of money being invested into the project. Just for the sake of the safety of your systems, I highly advise it. But so let's talk about some history and where the heck versions 1 through 3 went, because we've kind of seen 0s, 10, 12, and then we just jumped to 4. And what is the deal with v0, 12? So Node started with an alternating release strategy. Every even release was stable and odd was unstable. So 0.10 was a stable release and 0.11 was unstable. It turned out, though, that it was taking a very long time to get to v0, 12. And there wasn't even a clear path towards where v1 would even be. Personally, I like to start all my projects at v1, and there's kind of like, some debate there. Not having that first digit in Cember is a nice way to let people know, hey, this isn't stable. But then you lose an entire digit of granularity when telling your users what they can and can't do, or like what the updates mean. So not having that granularity stopped the project from doing patch updates for security in the same way that we can now. And the path to one wasn't entirely clear. So the project forked in December of 2014 for a number of different reasons. Brian spoke to some of them earlier. When they forked, they released version 1.0.0. This is interesting. First of all, releasing as 1.0 was actually the correct thing to do by Cember. It was kind of a new project. It was a breaking change because of all these different things. They did release with the same binary name, though, so there was like kind of a confliction there. But the project kept moving forward as 1, 2, and 3 following Cember as they moved. In February 2015, at Node Summit, Joint released v0.12. v0.12 did not have that much of a delta from 0.10. Primarily, it was an update to v8 and some internationalization stuff that was added. But it was not what was included in v1, 2, and 3 of IOJS at all. As I had said, they were all part of the IOJS project. Node was put into a foundation as a way to, have a peaceful resolution to the fork. And the projects merged as version 4.0.0 in September of 2015. So 4.0 was the merging of v0.12 and Node v3. So what we can see here is our long-term support release cycle. So at the top here, we can see Node v0.10 is end of life October 12th. October 2016. We can see v0.12 was in active maintenance and is now in maintenance mode and ends in December. We can see master is unstable and feeds into everything, and we'll talk about that in a little bit. Node v4 is currently in an active LTS process. So our LTS lines give us, you have 6 months as current, then it cuts into active LTS. You get 18 months of active LTS, and then 12 months of maintenance LTS. And I'm going to talk a little bit more in a minute about what those processes are. But so you can see that in April of 2017, Node v4 will move into maintenance mode, and we'll have a year of maintenance. And we can see v5, when it started, when it ended, v6, same thing. And this will just keep in perpetuity as Node moves forward. So every 6 months, we cut a new major version, and we flip things between different release lines as necessary. So I used a couple different words. I used current when describing version 6 right now. Our current release line is our tip of the branch release line. So every time that we're ready to do a release, which is like once every week or two, we take any Cember minor and Cember patch changes that are not relying on a Cember major change, and we cut a release. As long as those features and those patches have been approved and have landed on master, they're ready to go into a current release line. Active LTS is a slightly more vetted process. Once a patch has lived inside of the current release line for at least 2 weeks, we're able to then backport it to the active LTS branches. So in version 4, for example, every single new commit that lands on version 4 had to live in current for at least 2 weeks before it can do it. The main reason we do that is so that we can catch regressions and major regressions, and they don't end up in LTS. And that makes that release stream a little bit stronger and less likely to break. And what is maintenance LTS? So after we're done the active process, where we're actively backporting as much as possible, we move into a maintenance release line where we only will do patches for security releases and major breaking changes. So if there's like some really unexpected breakage that was only discovered later, that can be backported to a maintenance line. So for example, v0.10 and v0.12 are getting updated NPMs a little while ago. We updated from version 1 to version 2. And that's what happens in maintenance LTS. So what about master? Basically, everything lands in master. We don't have a develop branch. We don't have a production branch. Every single pull request lands directly into master. As soon as they're ready, they go there. So how do we manage all of this? Mostly magic. But more specifically, Git magic. A lot of Git. And because Git is magic with trees, basically makes us elves. But we maintain release branches. So for every release line, we have a branch that's gone off of master, v010x, v012x, 4x, and 6x. Each of these keep track of those release lines. If you go and look at those individual release lines, you'll see that the head of those is where the last release of that release line had happened. We also maintain staging branches, and each of these branches are used to stage changes before we're ready to cut a release. So, for example, the node inspector, the new inspector API, how many people have tried it yet? Can you see raise of hands? Oh, not many. So just so you know, there's a new API that landed in version 6, -- inspect, which actually allows you to connect to Node using the Chrome inspector and debug Node using Chrome. It's really, really cool. And a number of other vendors are actually getting their browsers to be able to work on it as well. So I know Mozilla has stuff working on that also. But so there was a whole bunch of changes and breakages that had happened. And we were able to take all of those and put it into the v6 staging before a release. So the release manager is doing it, knows that those are ready to land. The great thing about having a staging branch as well is if we ever have a major breakage or security vulnerability or something that we need to patch live or hotfix, we can branch off of the release branch and we don't have to worry about all those commits that are sitting on staging. And then we can rebase staging off of the release branch afterwards and we're back to where we were to begin with. So as I had mentioned, all changes must live in a release for at least 2 weeks before they're backported to LTS staging. And this is really, really important because it's the only way in which we can guarantee that we're not going to cause regressions and breakages. So let's do a little demo, and let's look at what this process looks like. So here's Node. And just in general, if I'm showing something on the screen and it's not big enough, just scream enhance, and I'll make it a little bigger. But so we look at the pull requests here, and we can filter by the label LTS watch v4. And we can see all the pull requests that need to be backported, that have not been backported yet. And now I can just go and, I'm just going to take a random pull request I have not at all vetted and thought about and made sure that it isn't going to break anything. And we can go through it. We can see, this is going to run npm install for the doc builds and the tarball. So when we build the tarball for Node, we strip out the docs, we strip out a whole bunch of stuff, including all of the Node modules for the doc builder, which means that it wasn't possible to build the docs from the tarball. So this just added something to the make file that actually will run npm install when you try to build the docs. So if it's missing all of those stuff, all that stuff, it will work. This is a great candidate for v4x. It won't break anything. It has a really low possibility of regressions. And it's just, it's going to make life better for people. So now what we can do is we can go here. We can see the commit that it landed in. We can copy the link address. We can hop here into the terminal. We can use this little command git patch it. It's an alias that I have I can talk about afterwards. We can patch that in. We can take a look in TIG. We can see the change. It does exactly what it says it does. And this is the best part. We just updated Node. So when we're ready for a release, we can branch off of one of those release branches and then cherry pick commits from staging. How do we know which commits we can cherry pick? Well, we use GitHub labels. So every single commit that we land has a label. Cember major, Cember minor, LTS watch, and don't land. This gives us the ability to filter through all of those and figure out what commits need to land and which commits don't need to land based on which branch we're merging. We also have tools that we use. Rodvag made these amazing release tools, including branch diff and changelog maker. So git diff compares trees. So every time you see a SHA in Git, that's representing a tree. It's a whole bunch of different files in the file system. When you're doing a git diff, you're comparing two trees and seeing what the difference is between those two trees. This is really useful if you're trying to see, hey, like what changes have I not staged, or what was the difference between this commit and this commit in the history of the project. This is not very useful when you're dealing with multiple release lines and what you actually care about is an atomic unit of change. So if you think about a commit as an atomic unit of change, it has nothing to do with the tree. It has nothing to do with the files that you've changed. It has to do with the effect of that change. So what's really interesting as you start moving between different release lines, the code in v4.x is actually quite different from master now, because so many things have happened and major changes that we haven't been able to backport. So when we actually try to backport a change, we're not guaranteed that we can just land it the way it was originally written. So when we're doing these diffs, what we actually care about is which atomic unit of changes haven't landed, not what's different in the code. And git diff doesn't do this, but branch diff does. So if, for example, we were going to make a 4.x release, we can check out v4.x. We could check out a new branch from it, and we would be doing 4.6.1. We'd be doing a proposal of it. We can now do branch diff, and we could say, hey, what's the difference between 4.6.1 proposal and v4.x staging? And it's going to take a second. It's going to go through, go on GitHub, grab all the information for all of those commits. It's going to compare them. And then it gives us this list right here of all of the commits. And this is like ready for a changelog. So what you can do, which is really fun, is you could say that the format is equal to SHA, so that we take only the SHA. We can reverse that list so that it's in chronological order. We can pipe that to xargs, get cherry pick. This is so much fun when it works. It's going to take a second. But so this is going to go through. It's going to grab all the SHAs of all the commits that don't land on it. It's going to reverse the list. And now it's going to completely patch every single one of them using xargs. It takes a second, but now it's going and it's actually building this release branch for us. Now, for what it's worth, this only works if you know that what's on staging is ready for the release. So we don't have anything that's in staging that we don't want to have on the release yet. So I can automate this process and know that it works fine. This is going to keep going. It's going to take a minute because there's a lot of stuff in staging. So the next version of version 4 is going to have a lot of great stuff in there. But now we can see we have this proposal. And you know what? Actually, later today, I'm going to go online and I'm going to make a proposal for v4.6.1 with this release that I just did here. Excuse me. We also have scripts that we use when we're doing releases that allow us to automate the process of taking the binaries that have been built in CI and promoting them. And through all these different tools, we can make the release process, a lot cleaner and more reliable. So I talked about a breaking change. What exactly is a breaking change? And a breaking change is anything, as I mentioned, that changes the contract and expectations. But they're not always, a breaking change is not always what you would expect. And sometimes extremely subtle things that may seem like they're non-breaking can be very breaking. So how can we make sure that we don't have breaking changes? So one of the ways to do that is with CI and Jenkins and tests. But the problem is that you're always limited by the tests that you've written. And if you haven't thought of an edge case before, well, you haven't written a test for it. So we also do something called smoke testing. I've been heavily involved in a tool that was originally created by James Snell called Canary in the Gold Mine. Canary in the Gold Mine is able to go onto NPM. It goes and grabs the tarball of a module. It runs npm install on it and npm test, and then reports the results of that. It also comes with a utility called sitgem_all. It has a list of 70 of the top modules from the ecosystem from a variety of reasons, whether it be most downloaded, most relied upon, modules that test particular subsystems, such as native modules or streams. And we're able to grab all of those and run all of those test suites. The thing that becomes really cool when you do smoke testing like this is that every single test suite in the Node ecosystem becomes a unit test for Node. When we want to make sure we're not breaking other people, we can run this. So if we make a change in Node that breaks someone else, we can go and take that and turn that into a unit test for Node to make sure that we don't break that contract. There is no reason that if we're not doing a Cember major change, that any module should ever break in a change in Node. So this allows us to figure out, did we make a mistake? So once upon a time, Canary in the Gold Mine found some failures. You can see that there was a failure in Jade, and there was a failure in Body Parser. So let's dig into these and see what it was. The Jade one was pretty simple. It turned out Jade changed its name to Pug. I'm not going to talk about that too much. It upsets me. But this was really interesting. Body Parser broke. How many people here know about Body Parser? How many people here know about Express? Express uses Body Parser. Every time you get a request in Express, it is running that request through Body Parser to parse the body. So, it may be a really, really bad thing if we broke Body Parser. We would break a good chunk of the internet. For example, PayPal, they have a platform called Kraken that I'm pretty sure they use to build PayPal. It's built on Express. We don't want to break PayPal. That wouldn't make them happy. So how do we break it? Well, this fix came in. It was actually a really great optimization. Query string has the ability to give it a max keys argument. And so what we were doing before is we were parsing everything. We had an array, and then we would actually just take a subset of that array if it was larger than max keys. So this is a problem in the sense that those array methods are slower, and also in the sense that we were creating all this extra garbage. So simply by using string.prototype split and passing the max keys argument to the split method, which you can do as an argument, we were able to speed up string prototype. As you can see here in the code, it was a pretty minor change. It was only about 4 or 5 lines. And as we were just saying, query string.parse is used in Body Parser, which is used in Express. This is really hot code. Even if we can optimize it by like 5 or 6%, that can make a huge difference on the entire internet. So of course we want to land that. But there was something we didn't think about, which was infinity. And so this is where things got really weird. The argument for max keys in string.prototype.split is expecting an integer. Infinity, inferred as an integer based on the JavaScript spec, is 0. So the effect here was that before the change, if you passed a max keys of infinity to this list, you would get back 1. After the change, you would get back 0. And I'm pretty sure that people who are passing infinity as an argument actually want to get something back. This isn't an academic argument about what the meaning of infinity is in integer space. This is, just give me the max number. Smoke testing saved the day. What was really cool about this is we actually had the change land on master, but it had not made its way into a release yet. As such, we were able to actually land the fix before it even broke anyone. So this never broke anything. After Canary in the Gold Mine has gotten more stable, we actually have it needed now for any Cember major change, any change that is questionable if it's going to break anything, and any release Canary in the Gold Mine needs to pass. So we are actively making sure that we're not breaking the ecosystem and breaking your stuff. This is how serious we take that contract. And Sikkim has found all sorts of weirdness, and I've kept a diary of it online, so feel free to ask me where that lives. I also gave a talk recently at NodeConfEU EU that you can watch that kind of goes more into depth about the architecture of Canary in the Gold Mine and some more really strange tales. But so, probably what you thought this talk was going to be about when I came up here, what version should you use? So version 4.x has had a while on LTS to stabilize, but this is really interesting. Version 6.x is actually going to be bumped to LTS tomorrow. So it's actually a pretty big deal. So why would you use version 4.x? Well, it's been hardened by an ongoing LTS process, which means that it is currently more stable than version 6. It's the least likely to break your app in production today. But I would almost push you to consider using version 6.x instead. Because it's only going into LTS tomorrow, it's actually going to have an entire extra year of active LTS backporting over version 4.x. It is the closest to master of all the LTS release lines. And also, it comes packed with V8 5.1. We actually upgraded V8 in this release line for the first time ever, and we used Canary in the Goldmine to make sure there were no ABI breakages. V8 5.1 has much better ES6 support, both for stability, speed, and functionality. I believe by the time you get to 5.1, it's like 99% ES6 compatibility. And that by itself is a great reason to move on to V6 instead of V4. Do you have to use LTS? No, I mean, you can do whatever you want. You're all adults, and I trust you to make good decisions. But V7 comes out in just over a week. And it's going to come with V8 5.4, which has a whole bunch of ES 2016 goodies in it. Like, I don't know how long you've been waiting to use 2 stars as an exponent, but I'm really excited about that. Or being able to use includes to check what's in an array. Like, this is going to be a node next week, which is super cool. Maybe I don't want to run it in production, but it doesn't mean I don't want to run it on my system. But if you're going to use version 7, just be prepared for breakages if you're an early adopter. As I mentioned, the current release cycle involves any Cember patch and Cember minor stuff that's ready to go. The purpose of current is to catch regressions before they hit LTS. So depending on your use case, it may make sense to be running on version 7. It may make sense to be running on version 6. I mean, you may even have a reason to be running on version 10. I don't think you should be, but I mean, as I said, you can make the decisions that are best for your organizations. So thank you all very much. This is an image of a puppy surfing. Thank you.